I am just going to give a quick presentation before we go into our technology scan section of the workshop. And so this is kind of going to be on energy transition plans and sort of talk about the pilot programs we've done with some of our growers, and then further go into the energy opportunities analysis, which has come out of a lot of those energy transition plans. So what is an energy transition plan? So an energy transition plan is basically an audit of your business. They'll come in, they'll do some background, they'll look at how much you're producing, they'll look at your energy numbers, they'll look at your emissions profile, and they'll do a load profile, and they'll figure out really how much energy your business needs and also how much it requires. Because a lot of the key points we've gotten out of some of these transition plans is that a lot of the boilers are actually oversized. For example, if your boiler is 3.8 megawatts, actually your total load profile it peaks at 2 megawatts. So your boiler doesn't actually have to be as big as it can, and that's one of the key findings we found out of these transition plans. Next, I'll go into the options for energy reduction. Could you go back? Thank you. Sorry. Next thing, they go into the energy reduction opportunities, and that's going to be one of the key points that we'll talk about today, and that's sort of a review of everything that they identified at your site, they being the consultants that we worked with. There is the different fuel switching options, so they'll give you a brief overview on all the different options that you have for fuel switching, and then their recommended steps towards net zero. So they'll say, these are the opportunities we think are the best. This is the fuel switching option that we think is best. And then the key importance that we're going to focus on, kind of trying to take a step back from the fuel switching, is understanding the options available for your site, because the more you can get your energy demand down, the cheaper your fuel switch is going to be when you do look at that option. So you go next, please. What is an energy opportunities analysis? So I pretty much just went through this. So do you want to go next slide? Thank you. Demand reduction opportunity. So let's take a look at what the consultants have talked about. This has been pulled from 6 different pilot programs. So let's jump into it. We'll go next one. Installation of air distribution fans. So the air distribution fans were identified as a cheap method for reducing energy usage according to some of these reports. They sort of range from about $4,000 to $10,000, ranging in size for the site from 1,600 meters squared to 3,500 meters squared. Depending on how your heating system is set up, it can provide really good returns. This is to make sure that the heat across your whole greenhouse is uniform, because you can get a lot of temperature stratification, so your hot air will rise to the top and you'll end up with cold air down the bottom where your plants need it the most. So the idea of the air distribution fans is to keep that uniform and make sure that it's all running correctly. So the additional benefits that you get from good air distribution are drives moisture away from the plants, reduces disease, and reduces the needs for ventilation by improving CO2 retention. So the negatives, obviously increasing electrical costs, and requires effective management to make sure that you're getting the most out of them too. Insulation. So insulation is probably going to be a brief one. I'm sure you all know the importance of insulating your pipes, also insulating your buffer tanks. Sometimes there was one example where the buffer tank was insulated, but the top of the buffer tank was not. And so making sure that you've got all of it is important, because it can save you quite a lot of money. And then insulating your boilers as well. If they're not insulated, you can lose quite a lot of heat and quite a lot of money out of them. It's not. Boiler modulation control. This was one that came up in one of the reports where the boiler only had an on-off cycle. So instead of being able to reduce, it could only run at 100% or nothing. And the reason why that causes issues is that if you only need a little bit of heat, your boiler will switch on and it'll ramp up to 100, and then 10 minutes later you don't need the heat anymore and it'll drop back down. And so you're constantly using way more fuel than you need to get your boiler all the way up just to turn it off again. So modulation control is an important one to look at if it applies to your boiler. For example, for this one, a 2.5 megawatt coal boiler, cost to install is approximately $130,000, providing $16,000 per year in savings. Next, please. Redirect pipe work for better heating of your crops. this was another quite unique one that was identified that I know I hadn't thought about before, was that a site had its pipework sort of sitting slightly above its plants rather than close to the plants. So it had to heat not only, it had to heat all the air around it to actually get to the right temperature that the plants needed to be. So if your pipework's coming out at 20 degrees, by the time that heat gets to the plant, it's going to be 16, 17 degrees. By redirecting the pipework to make it run directly underneath the plants, right at the base, to make sure it's getting all the heat it needs, you can see substantial savings, which is seen by the site analysed. It would cost about $5,000 to redirect this pipework with a $6,000 saving. So less than a year payback for this one particular site. Next, please. Reducing infiltration. So infiltration is air movement through the cracks and the basically the cracks and the of the glass houses. And so reducing infiltration leaks can save you about 3 to 10% in heating costs, according to some of the studies. And infiltration is significantly more of a problem for your glass houses because you have so many more cracks going through the glass houses. And one of the ways that was proposed to reduce the infiltration was planting hedges around your greenhouse. And if you do that, you can block up to, you can block most of the wind, and there's only a few problems like, there's the site planting cost of $6,000 with the savings of $4,000. Install thermal screens. So this is one we're going to touch on early. This is one of the more expensive options that you can go for if you're interested. Thermal screens have quite a high capital cost. They also require a quite modern greenhouse as well. It needs to have a reasonably high ceiling. It needs to have the right supports. It can't be being blocked as well, otherwise you need quite a lot of installation costs. And then it'll cost approximately 15 to 70 meters squared, which is obviously a huge variance, but the type of screens you can get vary quite significantly depending on what you need. Some people need more shading and less heating. Some people need maximum heating, less shading, and some people need a balance of the two. So what you get really depends on the price. High capital costs, but then again, it can provide exceptional energy savings. So a lot of reports I've seen are 30% energy savings with a 3 to 4 year payback in some scenarios. There's many successful applications of thermal screens around New Zealand. I can imagine some of you have thermal screens installed in your greenhouses and can attest to how well they do. We'll get a little bit more information on that later. Dehumidifiers, another high capital cost, but very interesting new energy saving technology. So energy savings reported up to 40% by consultants. For a 3,000 metre squared site, the capital cost is estimated at around $350,000. The additional benefits that they have are they provide exhaust heating, fungal protection, and improved air circulation. And there's a case study in Matamata for a grower, which I'll talk more on later. So yeah, I'm curious about what else you guys got. Is there anything that I've missed that you guys have done for your plant that you've seen significant energy savings, or anything that you want to share?
Question, like in Holland or in Europe, you see a lot of heat pumps going into the ground. I never thought there was any heat in Holland underground, but apparently there is. Why don't you guys do more about it here in New Zealand? I mean,
good question.
Well, with us, and you might have an answer later.
Okay.
Yeah. That is so we've got GNS Science here who are going to talk a bit more about, how we're trying to bring that technology more to New Zealand. There are some places who have ground source heat pumps already available, not horticulture, but they are out there, so touch on it. So I'll introduce Dean to you guys. Dean, he works at Elevated Concepts. He's done, he owns Elevated Concepts. He's done a lot of thermal screen work in the industry, and he knows quite a lot about the different types of screens. He's bought some samples with him as well, if you guys want to talk to him, but please stand up, Dean, and introduce yourself.
I sort of design and supply thermal energy screens. We have worked closely with a couple of suppliers out of Holland and Belgium, and It's just something that's for the bigger greenhouses has sort of always been around, but it's coming now with the energy cost being so much more adaptable for small greenhouses to put them in. And saying that, like you're saying, it's not adaptable for every greenhouse. A lot of people are asking for them to sort of smaller tunnel houses and bits and pieces. And it's not really cost effective for those sorts of things, but you can still design some systems to fit in there.
What about the different types of screens that are available? Sort of, can you elaborate on those?
There's many different sort of types of screens, and it's sort of site-specific again. There is a lot of new stuff coming out and with how much energy you can save and bits and pieces, sort of individual to the grower with light permeability and cumulative functions and that sort of stuff as well.
So there's a book for permeability for steel solutions.
Not quite at the moment.
Yeah.
There's opportunity in reviewings.
Dean, the payback on some of those screens that Hillary put some figures up there, is that for realistic under any more experience?
Well, I'm not a grower, you'd have to ask the grower really. I mean, definitely with the energy savings that they say from manufacturers and bits and pieces, are saying up to sort of 47% and that, but they do have some new boss out now that are saying sort of 90% energy savings from, but obviously there's not much light permeability through those, so they're designed more around to stop light at night time as well from people using grow lights and stuff as well. So it's sort of a combination. We don't in New Zealand currently worry too much about how much light is emitted from the greenhouse at night time, but it's something that's really got a lot overseas. And I think going forward, now with so many residential places being built close to the nurseries, and it's going to be something that is going to change.
Is that New Zealand specific? After install, like a year after, then seeing X reduction, or it is so site specific as to be possible?
Yeah, I guess it depends again on what you're sort of heating your greenhouse with and stuff as well. But when later on, you'll be able to get a bit more information around one specific site with Christchurch and put it in there and sort of we'll be able to say sort of what the dollar savings are exactly. I guess it's something that it takes a few years of monitoring to see benefits of that installation. Nurseries have been using them for years and years, but I think just with the energy costs being so high, those percentage of savings makes them a lot more viable than maybe what they used to do.